Alright, in this next video we will continue our look that we started here with building logarithm tables, okay, where we saw a relationship between, taking log of a number, log base 10 of a number, and then doing log base 10 of 10 times that number, so 20 in this case, and then doing log base 10 of 200, right, where we saw that when you multiply your original number by a power of 10, so like taking 8 and multiplying it by 10 to get 80, it takes your answer and adds a 1 to it. Okay? If we go even further still, and we take that 8 and multiply it by 100, it takes our original answer, log of 8 is 0.9031, and it adds a 2 to it, 2.9031, which makes sense because multiplying by 100, it's a power of 10 to the 2, right? 10 squared is 100. Okay, so in general then we could say right here that if you take the log of a number like x and you multiply it by some power of 10, that's equivalent to then just taking that power of 10, the k there, and adding it to your original log of just the value x. So let's see what happens here. So again, pause the video, or sorry, you can skip the video ahead if you want to. I'm going to fill in these tables here for log of x. Actually, we already have those tables filled in. So from before, let me just do this. So 1 again was 0, this was 0.301, 0, this would be 0.4771, 0.6021, 0.7782, 0.8451, 0.9031. Whoops, I missed one. I missed 5. 0.6990, 0.7782, 0.8451, 0.9031, and then 0.949542. Okay, filling in the rest of the table here then. It will be how can I do this faster? Log of x, and then okay, there we go. This will be better. Okay, so this will be -1 here. Okay, like that, and then all the rest of this table here will be -2. Okay, so then what patterns do we see here? Well, the 0 to the -1 to the -2 maybe makes the most clear pattern here. To get from 0 to -1, you subtract 1, right? And from -1 to -2, again, subtract 1. And the same thing is true here. All of these, we are subtracting 1. Okay? And then from here to here, we can subtract 2. Or from here to here, we can subtract 1. Okay? So write them in logarithmic notation. Log of 1 over 10 times x equals -1 plus log of x, and log of 1 over 100, because again we're multiplying by 1/100th here, from 8 to the 0.08, that's times 1 over 100. Okay, would be -2 plus log of x. Okay. What pattern then would we expect for log of x over 1,000? Okay, well, 1,000 is 10 to the third. 10 to the third. So we would expect -3 plus log of x. Like that. Okay. Compiling results from exercise 10 and 12 to make a conjecture about the value of the logarithm for a multiple of the power of 10. That is, find a formula for log of 10 to the k times x for any integer k. And it's the same formula we saw earlier. Log of 10 to the k times x will equal k plus log of x. Okay, and that's our answer right there. And so here you can see some properties right there. Okay, the notation log of x is used to represent, log base 10 of x. We talked about that in the previous video. For integer k, log of 10 to the k equals k. Okay, and then also, this is a very important property too. When you have multiplication inside of a logarithm, you can change it to addition between two separate logarithms. So notice here we have 10 to the m times 10 to the n inside of this single logarithm here, and they rewrote that, broke it up into two logarithms here. Okay, where it's log of 10 to the m plus log of 10 to the n. Okay, and then so that's a property that's going to be true for any log base, regardless of whether it's base 10 or if you have log base 2 or whatever kind of thing. And then here, when we have log of 10 to the k, again we can use this multiplication property here, where we can have multiplication. Sorry. And we change it to addition between two logarithms. We can do the same thing here as well, where if we just take that log of 10 to the k plus log of x, then we know what log of 10 to the k is. It's k. So we'll just get k plus log of x, which is exactly what we see right there. Okay. All right, very good. Thanks, guys, for watching. We'll see you in the next lesson.